Yes, all good to go.
Awesome. Awesome. Thank you, everyone, for joining this session. We put this session out probably a month ago when there were quite some updates in the agentic AI space itself. So we wanted to kind of cover a bunch of updates and also give you a good idea of where they fit in the pipeline. So that's what this session is all about. So last year, most of the discussions were generative AI, generative AI, generative AI, right? Most of 2024, people were heavily using that term. There were a bunch of different applications in Gen AI. And this year, maybe more so even in the end of 2024, we've been talking about agentic AI and AI agents. And if you really think of it, these are following up from waves of innovation, which probably include traditional software in the beginning. And then maybe in the late 2010s, we're talking quite a bit about machine learning and deep learning kind of approaches. And just over the past 3 or 4 years, we've been saying generative AI and agentic AI, right? These are kind of different steps of innovation if you look at it in the automation space, in predictive space, etc. So before kind of going over this agentic AI term, I want to take a step back, do a quick recap, and say what actually made Gen AI take off. Like what, because Gen AI is kind of what gave a lot of momentum to different terms that we're hearing these days. So I want us to be on the same page. So really think about what made Gen AI take off. And most people would obviously say, duh, because it was generative, it was generating text and it was generating images, which wasn't done before at all. But I have to kind of give you a different perspective to this, and that is this, right? If you think about traditional software, machine learning, deep learning, and all of these things, there's always some format of interacting with these systems, or more of some format of building these systems. For instance, if you had to go and build traditional software, you'd have to learn to code Java, C++, Python, and all of these different languages. With machine learning, we figured that, okay, in traditional software, we really have to write a lot of code. And if you're doing some kind of predictive things, maybe why not just feed in the data and let models understand how to make predictions, right? And then there was this whole concept of how do you do feature engineering, how do you train your models and stuff like that. And later we said machine learning is a little annoying because who would sit and have time to do all the feature engineering? We have neural networks that can probably understand how to pick the right features when you're doing tasks like image classification or like sentiment analysis and these kind of things. Then we moved to this paradigm of using neural networks where you're still training models for narrow tasks, right? And every time you had to implement a new thing, like think of enterprise use cases like recommendations or fraud detection and all of these things, it was much easier to build these systems, but you still had to train them. You have to get some amount of data in order to train your models. But then with generative AI, the paradigm kind of changed. And if you really think of it, all of these previous approaches put kind of a wall, kind of an interface between the user and the system itself. And with generative AI, that kind of changed to you can just talk with your system. You don't really need to have this interface in between, right? And it would pretty much understand out of the box. I know there's this concept of prompt engineering, but really think of it, it's as simple as talking to a human being, and any changes you want to do happens in the language space itself. You don't need to learn a different either training or feature engineering. There is that wall is kind of removed for generative AI, right? Which kind of makes generative AI pretty cool. So I would think the best part of generative AI is not generation, but understanding humans zero shot, understanding humans like other humans would do, which is natural language. And zero shot just means you don't need to train it specifically. You don't even have to give it previous examples, right? So the real breakthrough of Gen AI lies not just in generation, but in zero shot natural language understanding. And we went from this entire concept of I'm going to train my AI system to do a particular task to I'm just going to talk to my AI system to do a particular task, which makes a huge difference because it opens up the space to a bunch of different people who don't probably know how to code, who probably don't know how to train models, etc. They can still interact with these systems and get reasonable outputs from them, right? Now we are in 2023, 2022. ChatGPT came up, and we have these systems that can understand text. We also went further to say that they can understand images and videos and stuff like that, and they can also generate all of these kinds of data, right? Which is pretty cool. We have systems that can talk to us in natural language, and they can also generate natural language for us. But obviously we're humans, we are never satisfied. We want to build on top of things that already are available, which is kind of the way progress has happened in technology. So in late 2024 or mid 2024, people start figuring out that Gen AI models can understand and generate text. They can generate images and videos, not so well, but they can do it. But they can't complete tasks end to end, right? You're almost communicating with these systems like you would do with humans, but these systems are just there answering questions for you. They can maybe suggest travel itineraries to you, but you'll have to use that and go and make bookings in whatever website you use, right? Can that also be automated some way? Can AI systems actually book tickets for you? Can it remember preferences and personalize things for you, right? And if you're building these enterprise systems where you're probably having employees ask questions from internal enterprise data, can they actually go and achieve tasks as well? If an enterprise search system can tell me how many leaves I have, can it go and apply for a new leave and stuff like that? Now, the TLDR here is that can AI really plan and execute tasks from end to end using existing APIs and software instead of just giving me answers to something? Because at the end of the day, using those answers, humans have to still kind of achieve tasks. So that's where this entire concept of agentic AI came in, which is how do I provide Gen AI some tools so that it can act on AI model generations? And there are three components of agentic AI, which the first one is tools, which are basically APIs or code executors or websites, etc., that the AI model can interact with. The second component is generally called as memory, or what you would store in databases, some information that the Gen AI model can retrieve and come up with answers. And the third component is not really a component, but a way to push your Gen AI models to plan, right? Because all this while we've been kind of interacting with these systems, but we've not given it higher order goals to achieve. So when we give it higher order goals, can AI systems actually plan step by step and come up with a roadmap to achieve something? So this essentially is the idea or the base assumption for what we want agentic AI to do, which is to act on AI model generations, right? So Gen AI plus these three components basically give rise to what we call as agentic AI. And if all of this kind of feels like theory, I want to show you a quick example that kind of helps you understand this. Say you have a task that says, book a 10-day vacation to Europe for me. What the AI model does is, this model is right sitting over here, and then it says, okay, in order to book a 10-day vacation, I probably need to be retrieving the user's starting city because I need to know where to take flights from. And I need to use Emirates API to search and book flights. This is a very simple example. I'm trying to narrow it down. There'll probably be, some choice on how it chooses the different APIs and stuff like that, but just to simplify it for you. And then it says, based on the confirmed flight details, I can use maybe booking.com's API to reserve hotels, right? The AI model is still generating all of these text. And then you send that information back, and then it says, okay, now since I know that I'll have to retrieve the user's starting city from memory, the AI model says, okay, I'm going to generate a SQL query because this is a SQL database, and says, okay, I'm going to select user city and dates from the table, and let's say the memory returns back the city, right? And then that goes back, and then the AI model says, okay, now I have the city. I'm going to query Emirates API in order to make the booking and stuff like that. And then the API comes up with a list of available flights and stuff like that, right? If you really think of it, the AI model is still generating only text, but there's a lot of engineering that's happening here in order to connect the model to these different components, right? So the plumbing is actually being done by good old engineering. And you're seeing that from just generating something, you're going to actually complete a task end to end. Now, these kind of agents started working pretty well. I think in late 2024, there were a bunch of different initiatives to kind of make sure that we can build systems that can achieve tasks by giving them access to this planning, memory, tools, and all of that. But then people figured out that while this is possible using large language models for which were available at that time, these LLMs were kind of having a hard time doing the planning itself, right? Why were they having a hard time doing the planning? Because AI models originally, when they came up, they were designed to be chatbots. They weren't built with inherent reasoning capabilities, right? The kind of training data that was used to train these models was not in order to enable planning, because this was kind of a new approach that came up. So in real world scenarios, when things get very complex, when they're multi-step workflows, it's kind of unrealistic to expect them to, break down a larger goal into smaller steps and all of that. There were a lot of prompting methods which kind of push these LLMs to generate like chain of thought, to kind of plan and solve things, etc. But they would also hit limits, like when you're giving them very complicated planning scenarios, because these models are just trained with something like this, right? There's an input statement and there's an output statement. Then I think in December 2024, OpenAI says, let's probably come up with this new set of models, which we call reasoning models, which are specifically trained to handle multi-step problems, right? So they don't only generate answers, but they also generate a planning process. And you can basically use these to reason and plan, which very nicely falls into your agentic pipeline as well, because planning is a heavy component there. So it makes them far more effective than plain LLMs when they're used for complex tasks. And these models, these reasoning models, are basically trained to take in input statements, and then they probably generate output statements as well as some planning or reasoning statement, which helps them break down, right? Remember this, the trick is all in the training data itself. There are obviously a lot of ways in which reasoning models are trained and how they're trained differently as compared to LLMs, but that is kind of the crux, right? Which is push these models to even take ownership of their planning itself. That's kind of the main idea. So from end of 2024 to Q1 of 2025, we have seen the space of reasoning models catch up very quickly. OpenAI O1 was probably the first reasoning model, and then they released a smaller model, which was O3, and the latest DeepSeek model, which is gaining a lot of momentum, also is a reasoning model which uses similar methods. And Gemini came up with their thinking series and all of those things, right? And Anthropic said that these reasoning models are reasoning too much. For every simple question, they're planning too much or generating too much of chain of thought. And they said, why don't we train models so that they can think when required? And that's when the space of hybrid models came up to be. Claude 3.7 is a hybrid model, which means that it first determines if a particular query requires extensive thinking, requires extensive planning, and then uses planning as required, right? Remember that this is a very emerging space. It has a bunch of different challenges. There's active research in the space that says reasoning models overthink a lot. They sometimes generate too many output words. Most LLMs, kind of the cost is directly proportional to how many input words they consume and how many output words they produce. So if models are producing too many output words, that increases your cost for operating these models. There's also this problem they have, which is called reward hacking, which means they get to the final answer, but not in the ways that you would want them to. The planning approach is kind of sometimes screwed up. So these are high level what issues are happening with reasoning models, but they definitely open up the space for us to build much more powerful agentic systems. Over to Kiriti to talk about tool usage as well as MCP. He's been doing quite some work on it, so I'll hand it over to him.
Okay. Can you folks see my screen?
Yes.
Okay, perfect. Yeah, so let me see if I have control over this. Okay, cool. Yeah, so so I should have covered a bit about the planning component of the agent. Let's double click into tools and what they mean, what do they do, and how do they tie up with agents and MCP and all this story. Want to just give you like an example of how we take a component and deep dive in this course, and let's go with tools. So just to recap, right? AI models can actually, like understand your questions and answer in like different formats, like images, text, and everything. But really, they can't, touch like quote unquote human world where you want to do some actions in your like services or in your like software. So tools are a way to like bridge that gap. Tools basically allow the agents to actually reason and act on your behalf, like whether it's like fetching information or actually taking some action. So let's take a step back and see how tool calling works. So tool calling is, or like some people refer it as like function calling. So this has been introduced like by OpenAI, like like in June 2023. So this is not new. This has been around for almost 2 years. So basic definition of tool calling is like, hey, LLMs work well with text. They can take in text. They can generate text. Now, how do I give them the functionality to actually do something with it? So what tool calling is that you are providing a description of tools in a JSON format. So JSON, for folks who are not familiar, is just like a structured format of like, this is the key, this is the value. So in this example, let's say I have a small tool designed to say get weather at a location. So I'll just tell the LLM that, hey, this is the tool that you have or like the function that you have, saying this is the name, which is get weather, and some description on what it does and some parameters, and say I need a location parameter to understand where I need to actually get the weather for. And given this tool description, now if you send the query to an LLM, say like, how is the weather at New York? If you just ask this to a regular API, it cannot answer it because it doesn't have this information real time. But with tool calling, what it can do is not execute the tool, but only tell you which tool needs to be called to get the relevant answer. So LLM would produce some tool call message, say something like, I need to do a function call with this get weather function, and then send the location as New York, USA. And this is extremely important. A lot of people confuse that LLMs can actually execute the tools, but they don't. They just map the question to what tool needs to be executed, and then you as a user will execute this tool on your Python environment and then return the response in a certain format that the LLM expects to. So you're saying, hey, I'm a tool call message, and then I call this function, and this is the answer. Now you send the result back to the LLM again, and LLM remembers the query and then like takes the result and then summarizes the answer saying the weather in New York is now is 58 degree Fahrenheit. So this is an example of how tool calling or like function calling works at a very high level. So now, how is this relevant to agents? So if you think at a high level, like agents are not doing anything special except like, doing this previous procedure that we talked about in just like loop. So let's say you give it a complicated question, the agent will break down, which is the plan generation part of it. And then they continuously go through this loop of, it decides what is the right tool call and what are the right arguments to provide to that, and then user environment executes the tool call and then like generates the result. That's the observation part of it on the right here, and that observation goes back to the LLM and now it decides, okay, I have this information, now what else do I need to get it? And then this repeats this process over and over and over, and once it gets all the information, it combines all of that and then it generates a final response. So you can think of tools as like, not just read functionality, but write functionality. So in the use case that Aishwarya mentioned, if you have something like book a certain flight to a location, you can imagine there are two tools, one for checking the flights, and once you get the results of all the list of flights, then actually book the flight, like, select a flight and then like call another tool to actually go and book this flight. So that's what tool calling generally does. Now, does this solve all our problems? Not really. As we have seen, like, once you start using more and more of like a certain thing, you kind of like identify what are the drawbacks of it. So what are the drawbacks with tool calling? So let's say you are a company like, I don't know, like booking.com or Emirates. You have your APIs and now you want to expose your APIs to large language models because that's how everybody's operating these days. So let's say there is OpenAI and they say, hey, this is my format of like, providing the input to the LLM and this is how you should return the tool call response to the LLM. So you write all these custom APIs to plug into the OpenAI model, and okay, life's good. But then there are all this new set of models that are coming in, like Anthropic, DeepSeek, Google. They also do have JSON descriptions, but they don't exactly follow the same format. Now you're like confused, like you need to like write custom integrations for each of these model providers. And as you can see, it becomes like a incredible headache to actually do this effectively. So that's exactly the reason why Anthropic came up with this thing called MCP. If you think of MCP, MCP is called Model Context Protocol. So the model context just means like, how do you provide context to the model, which is basic. And then protocol is the main part. Protocol is the part that they're saying that, hey, everybody who needs to develop a tool can just adhere to MCP. And now every model provider will actually talk in the MCP language so that you as a tool developer don't need to go and like develop custom tools for everyone. So think of it as like a language that's been invented to just unify how tools communicate with models. That's all MCP is. MCP did not like say invent actual tool calling. It's just like kind of standardizing how things are done across tools and across models. Uh, so you can say, think of it like, if you are an iPhone user for like up until 2 years ago, you had this Lightning port and then you have this USB-C port for your other devices, and that's like a lot of mess. So think of MCP as like a USB-C for like AI. Now you have this common USB-C port, and now different servers can plug into it, and then different clients like Cloud Desktop, Cursor, Windsurf kind of IDEs can also speak the same language, and now everything works seamlessly. So now you don't have to think about like designing custom fit solutions for each client and each server. So you can ask, is MCP just like, telling me how to specify the JSON? That is the immediate impact, yes, but it does a bit more. So MCP kind of standardizes how tools are described. It also standardizes how requests and responses are formatted. If you remember this slide here, we are formatting the request to the tool and the response from the tool in a certain way. This is OpenAI spec, but Anthropic does it in a slightly different way. So MCP is also standardizing all of this. And once you have this sort of standardization, now you can actually talk about richer components, like, not just text, but you can think about how do I stream audio? How do I give LLMs video to do certain things? So that's like the real innovation that comes in with MCP. So let's take a quick understanding of how MCP actually works. So MCP has three components. It has a client-server architecture. What I mean by that is like there are servers which do a particular set of functionality on a given data source or on a given service. You can think of like Booking.com implementing an MCP server, Emirates implementing an MCP server, and so on. So and then there is client. A client is a tool basically which has LLM attached to it, and then it talks to these servers using the MCP protocol and understands, how what are the tools available for me in this service and how can I communicate with them to get the work done. And a host is actually a terminology for like a host of clients, like it's the entity or like the software like Cloud Desktop or IDEs which actually host these tools. If you have used Cursor, for example, you can think of the clients living inside Cursor and communicating to the MCP service. So what else did MCP do? So MCP kind of split the responsibility into client and server. So now you don't need to worry about all the API implementation in the client part. You can just say LLM connect to this server, and then now you are like super capable of doing these things. So another advantage is like, up until recently, a lot of LLM related code used to be written in Python or sometimes in Node.js. But with this separation, now anybody can write an MCP server. All you need to do is talk MCP protocol, and now you can write in, Java, Kotlin, Scala, or like any kind of language. In addition to that, now you have all sorts of traditional software engineering goodies, like you can implement scaling of these MCP servers, you can implement rate limiting, you can implement authentication, all sorts of things without actually worrying about how others are going to use your service. So while MCP at a higher level is just standardization, it has a lot of underlying benefits on how you split this into a client server architecture and then actually have it do a lot of amazing cool stuff. So to recap on MCP and like this tool calling, MCP is basically standardization of communication, but it once you develop like an MCP server for like a particular protocol, now anybody in any host can use your servers. So this incredibly accelerates the AI adoption. Like you can see people just like downloading Cloud Desktop, downloading an MCP server, and just like go do build amazing products with that. One catch is it's in a very early stage. I think only recently OpenAI and Google have agreed to adopt MCP, but it is not set in stone that this is going to be the protocol of the future. There are drawbacks for this, and it's not a silver bullet that solves every problem out there. But it is good to understand why MCP has been created and what was the state before it and how it's going to be useful. So just wanted to give you an overview of this is how we will take a problem, come from like the scratch on how it's been implemented before, and describe the state of art things in our code. So let me hand it back to Aishwarya from here.
Thank you. That was a quick run through of MCP. Our, our 6-week course will have an entire module dedicated to it and a bunch of scripts as well. This is what we can do in a lightning session, but hope it brings you more clarity. Now, the idea is there are all of these updates happening. There's reasoning models, there's MCP and all of that, right? Like, let's take a step back and see where does all of this fit and how does this change the way we design agentic AI systems, right? Because we're tackling this through a builder perspective. Yes, you can be a user, you can use a bunch of these things, but when you're leading teams, when you're kind of building strategy for your company, when you're maybe implementing these things, what does it even mean for us, right? Um, there are so many updates happening in this space that we kind of want to flip the narrative here and kind of say, maybe think of it in a problem first approach. What does that mean is let your use case drive the decision. So analyze your data first, start simple, and prioritize the problem before the solution itself. You know that MCP, reasoning models, new kinds of models are all arriving, but where do you fit it in the entire pipeline? And in order to explain that, we have this concept of what we call solution design and then iterative solution design. Regardless of what new tools or what components come in, the way you design AI systems is pretty much consistent. I think I put up this slide back in December, and this kind of an approach still holds. And kind of basing your understanding of these new tools using this framework of how you're designing systems makes much more sense than just listening to a bunch of things in a scattered way, right? Generally, when you're designing AI systems, this is pretty much the approach that you would take, right? You would first identify the use case, you would curate data for the use case. Using the data, you learn from the data and what kind of inputs you might be getting into your system. You choose the application, the model and the application design, and then you set up knowledge, you set up tools, then you design the application, you have to curate evaluation data, design a bunch of evaluation metrics, and then you get the final application, right? And the fun part about AI systems is this is not a once designed and done kind of a situation. You'll have to iterate multiple times because you have to learn from your evaluation metrics and kind of do optimization, multiple optimization runs, right? um, so essentially you kind of have this loop where you identify gaps and you further optimize. To kind of give you a quick example of what does that mean in maybe an enterprise problem, this is one of my favorite problems I bring up all the time because it's one of the most common enterprise use cases. Let's say we have something like design an AI powered employee chatbot that enables employees to inquire about company documentation, HR policies, and all of that, right? A lot of different enterprises have tons of scattered data and they want employees to be able to access it pretty easily. Now, how do you go about designing this kind of a solution is you first narrow down on a set of 2-3 features. Most people try to say, I know that multi-agent systems exist, so I'm going to just put them here in order to solve my problem, right? that's probably the worst way of designing systems. You'll have to start from the problem. You'll have to curate data. What are the kinds of questions employees might be asking, and what are the right answers? You'll probably have to use some amount of synthetic data to do this if you have never built the system before. And then comes your model and application selection, right? And in the course itself, we focus on different levers in the enterprise, for instance, performance, cost, latency, effort, and these kind of things. And that's where you really need to be thinking, do I really need reasoning models? I know it's a fancy new thing, but what will guide your decision is your data itself, like what kind of problem you're solving. And then you can really see that data and think, do I need extensive planning here? And then probably use a bunch of leaderboards in order to understand what kind of models might fit into your picture and how they fall on this entire graph of performance, cost, latency, and all of that, right? And then you think, do I need vector databases? And understanding the business constraints, you make a call as to, should I be using MCP at all? How many existing MCP servers are available in my I mean, for the application that I'm currently building? Sometimes it's possible that a lot of enterprise APIs are already well built, and you don't even have to use MCP unless you're kind of making this a very large scale project, in which case at some point you might have to bring in standardization. But remember, MCP is also a very new protocol, and it's not widely accepted. It's not as widely accepted as HTTP. And tomorrow someone might come and say, we're going to define a different protocol, which is more seamless. So kind of keeping the business constraints in mind, what are your timelines? What are your SLAs? That's where you need to be bringing in these choices instead of saying reasoning models are available, MCP is available, I'm going to put it into my application, right? Following this cycle and making your design decisions as a part of the solution design is much more optimal to do as compared to coming up with the technology first. And both Kirit and I have worked on 100 plus enterprise AI use cases. We've developed a bunch of different POCs and also advised them. And we figured that in reality, 90% of enterprise use cases don't even need heavy reasoning models, at least not when they're building their version 1. So there's a huge gap between what is being discussed in AI research today versus what works in the enterprise and what kind of business constraint they are. So you really need to understand that difference instead of going technology first, right? And then apart from that itself, you need to be having a very airtight evaluation setup. A lot of folks kind of build systems and they're not able to understand what their bottleneck is. You'll have to design unit test cases, regression test cases, and we bring up things like LLM based evaluation and things like that. If you don't understand it very well, it's totally fine. We just want to tell you that these are the steps that you need when you go about building a system. It's not just picking up some technology and building a prototype out of it. Maybe it does work for simple prototypes for like productivity, for your own productivity, you're building something because the stakes there are not very high. But when you're building a customer facing product, all of this is super important. Then you have to build and run your system. You have to implement different kinds of monitoring. Agents are notorious for doing tons of LLM calls, which you sometimes don't have control over, for increasing the latency of your system, for increasing the token usage of your system. So having a monitoring pipeline is really important when you build agentic systems specifically. And then you kind of go to your optimization phase, right? Once you've kind of built this very simple V1 and you understand your system end to end, that's when you say, okay, maybe my evaluation metrics tell me that there's quite a lot of hallucination happening, and I probably have to provide more data in order to improve this, or maybe change my design, give lesser autonomy to my agent and things like that, right? And unreliable tool usage is a heavy problem with agentic systems as well, and this might be happening because your tool definitions are not given to the agents very well, or because one particular agent is handling hundreds of tools and APIs and it's kind of getting confused. And that's where you need to think about whether I need to have a multi-agent system for this, or do I need to improve my tool specifications and things like that, right? So you can always split this designing of agentic systems from a simple design, something that works end to end, and then start understanding the problems, because you've kind of put together this framework that gives you more visibility to how your systems are working, and then work on the optimization instead of saying there are tons of new optimal techniques and I'm just going to put them in my system. It just makes it even more unpredictable, right? Now, that's kind of the summary of building agentic systems in 2025. Yes, a lot has changed, but you need to really think about what are the new components and do they really fit into my pipeline? Do they really fit into my design? Instead of saying that I'm going to start with adding these new components, right? So think of new updates as a additions to your existing pipeline for the use case and not the other way around. And that kind of a mindset makes it much easier to build with AI, and especially because AI is a space that's moving extremely quickly, and you need to find a way to ground all of these learnings into a paradigm instead of learning it in a very scattered way. So here's the summary. In 2025, the real power is not really knowing things. A bunch of people come and tell me they've learned 100 different ways of building multi-agent systems, or they've learned advanced rack techniques and stuff like that. But most of the time when I throw a business problem at them, they don't really know when to use what. And that is where I move to explaining about our course itself. Building agentic AI applications is a problem first approach. We ground it to this iterative solution design and also build in complexity, and do this from a problem first approach, so that you don't get confused by a bunch of different things coming in. You kind of see technology as a bigger part of your problem solving instead of doing the other way around, right? Most of our course teaches you applied concepts on how do you build agentic AI systems, but always grounding it. And um, this is everything that comes with our 6-week course. It starts on May 23rd. You will be designing an agentic AI. You will be designing your own agentic AI search system from scratch. So we call it Perplexia just for fun. So you'll kind of be understanding how do you start from a simple business problem and move up to an agentic search system. There will be low code tools as well. We use Langflow, which is a drag and drop pipeline in order to build AI systems. We don't use things like Zapier, Lindy, and all of those things, because you don't understand the internal working of these systems if you used such heavy automation systems, as well as you'll also see why those don't scale in production. We'll be covering those as well in our lectures. And you will have lifetime access to all future cohort materials, because this space is moving quickly and we want you to be having access to the recordings as well as any new material that we add. We will be reading and analyzing over 30 plus research papers, but these will be the ones that will be relevant to enterprise use cases. A major part of our course is also kind of teaching you how to read research papers in a way that they can be applied to the enterprise, instead of digging yourself into understanding every nitty-gritty of it, and also being able to filter out the noise that comes up with all of this research, right? How does this really fit into my enterprise use cases, or is it really something that I need to be reading? A big component of our course is also to make you a power user of agentic tools. A good builder should also be a good user. So we kind of seamlessly integrate Cursor, Notebook LM, and these kind of things into your assignments as well as the course learning, so that you kind of get very good at using these, right? And a fun part of this course is also we meet every Sunday to have what we call Chai and AI sessions, where it's just a bunch of us unscripted discussing what is happening in AI and how do we kind of think of it. And as problem first thinkers, what does that mean to us? So these are pretty much just conversation sessions. The final part is a capstone project. I don't know how many of you attended our capstone demo day last week, where you will be taking a very high level business problem and designing a solution for it using the principles we learned throughout the course. We got a lot of praise for our previous cohort students. A bunch of products they built, they will be building on top of it, and we got comments that these could be actual startup ideas. So we are super proud of them for what they've done, and we hope to see similar ideas in the next cohort as well. And of course, we'll have industry speakers, folks who are not going to be telling you that AI is this fancy thing that's going to change everything, but are actually going to come and tell you How do you build systems? What are the issues we are seeing in the enterprise, and how do you kind of use those learnings when you start afresh, right? This course is basically for people who want to lead AI strategy, who want to think about how do you build products for customers, and this can be product managers, C-suite folks, and engineers, data scientists, and all of this. And again, like there will be low code options, as well as for the low code we'll be using Langflow, and for the code we'll be using LangChain plus LangGraph in order to build your assignments and all of that. So I will also, we have a special coupon today. You can use AGNT 250 for a $250 off, and if you run out of that, you can use AGNT 150 for a $150 off. I will keep this slide and basically take questions from folks in the chat.
Yeah, I think we have some questions in the Q&A. For some reason, I'm not able to respond in the chat. So folks who are asking questions in the chat, please use the Q&A section at the bottom of your screen to add it. We'll go over them and like answer in live. Aishwarya, so I had to leave and join the Zoom meeting, so I might be missing a few Q&As. So let me,
Okay, I can read them for you.
yeah, I can go ahead.
Okay, so there's this question that says some LLMs can return two tools at a time in a single call. So am I right in saying that the LLM planning in a single invocation?
Yes, you kind of, yeah, you can think of it like that. So you can actually have like two tool invocations and like get the results of those in like a single shot. But I don't think it is good to say that it is planning at the same time, because all it's generating is like I need to do these tool calls, whereas it retains the context of the plan from the previous messages.
Awesome. There's a question that says, what are the prerequisites for this course? The prerequisite is you should have coded at least once in your life, even if this is maybe 10 plus years ago. Honestly, a lot of our lectures do not require coding knowledge, but the assignments might become a little more simpler if you've coded at least once in your life. Langflow is a no code platform. Like I said, it's a drag and drop kind of a platform, but we just think you will have to take a little more time if you have never coded before, because just those abstractions might be easier to understand.